Good morning. Thank you for participating in Morehead at Home Skywatching, hosted by Morehead Planetarium and Science Center. My name is Amy Sale. I'm an educator at Morehead. We are a unit of the University of North Carolina at Chapel Hill, located on campus. We also work throughout the state through a number of outreach initiatives like our mobile lab vans, summer camp programs, and the annual North Carolina Science Festival. Our mission is to help people better understand science, technology, and health, and we do this through engaging learning opportunities like this live virtual event. We're happy to have you here for our program today on deep sky objects. And Nick will get us started.
Thanks, Amy. Hello, everybody. Welcome to Morehead at Home Skywatching. We're happy to have you here with us today. If this is your first time, we will give you an introduction to how this works. But if it's not your first time, welcome back. Today's topic is really interesting. It's deep sky objects, and in particular, the Messier catalog. So we're talking about objects that are outside of our solar system, things like star clusters, nebulae, even distant galaxies. And we're going to kind of tell you a bit of a historical story of a particular astronomer and his contributions. And we're going to share where to find some of these things in the sky and maybe even some up close images that we couldn't usually get through our eyes or our backyard telescope. So with that, I think I'm going to get started sharing things. A couple of housekeeping items. We want to answer your questions, but the only way for you to send those to us is to use the Q&A function at the bottom of your screen. So if you have a question about something you see on the screen, something that kind of pops in your head that you're curious about, please put those in there, and we will try our best to answer them towards the end of the program. Also, I want to shout out the program that we're going to be using today to share the sky. It's called Stellarium. You can find it at stellarium.org. We'll put that link in the chat for you. It's kind of like a flat screen planetarium. So it's a neat way to simulate what your sky is going to look like. It's very customizable, and you'll see that it can take us far beyond what our eyes can see. And with that, I think I can go ahead and give you a look at what my Stellarium screen looks like. Okay. So here we are. This is a daytime sky for those of you who have maybe not seen this view before. It's a daytime sky from somewhere like Chapel Hill, North Carolina. Now, if you're joining us from outside of the triangle or in central North Carolina, your sky might look a little bit different. If you're here in the southeastern United States, this is going to be about what you can see. But you notice it's not a view you'd have when you step out into your backyard. We've taken our three-dimensional sky and shrunk it down and distorted your view a little bit so that you can see a lot at once. So for reference, I'll adjust us here a little bit. We're facing towards the south. You can see this big red letter S here. That means west is on our right, east is on our left, and high above us, maybe somewhere in this part of the screen, this would be the zenith or the top of the sky. So that's useful because this stuff up here is not what you would see when you look right in front of you in your backyard. This is some of what you would see when you're looking up. So there is one thing up in the sky, that is the sun. We're going to make it dark before too long, but I think we wanted to talk a little bit about some of the historical story behind our topic today. So I'm going to pass this over to Amy.
Okay, yeah, so as Nick mentioned, we're going to show you all how to find some deep sky objects. So objects outside of our solar system. Generally what we're talking about are star clusters, galaxies, and nebulae. And I see there's already a question about whether exoplanets would count as deep sky objects. I would say no. That's not usually what we're talking about, although exoplanets by definition are outside of our own solar system. We're going to specifically talk about some deep sky objects that were cataloged by a French astronomer who was born in the 1700s, Charles Messier. And his love was comets. He liked to hunt for comets in the sky. And comets, you can think of them as cosmic snowballs made of frozen gases and rock and dust, and they can be about the size of a small town. And then when a comet comes in close to the sun, gets all heated up and spews out dust and gas into this beautiful tail. And we actually have a image of a comet that was taken recently, and oh, Nick, thank you for showing that. This is Comet Neowise, which was discovered earlier this year by a NASA spacecraft. Neowise is an acronym of the name of that mission, and it's hunting for near Earth asteroids and comets, and discovered this one. And This image was taken actually this week from North Carolina from an astronomer with the Raleigh Astronomy Club. And don't expect to see it looking like this if you happen to go out and try to look for it. It's actually, this image was taken, the astronomer reported that it was barely visible to the unaided eye. So, but this is the camera picture of it. So this is the kind of thing that Charles Messier wanted to find. Now comets, they appear in the sky and then they go away, and they appear to move from night to night. And they look like fuzzy objects in the sky. The problem is there are a lot of fuzzy objects in the sky. So Charles Messier made a list of the ones that he saw. He made a catalog of over 100 objects. He's credited with discovering some of those objects. Others he just noted that they were there. And they were objects that didn't appear to move against the background of the stars. And that's how he knew they weren't comets. So it turns out that Charles Messier's list of not comets turn out to be some of the most beautiful objects in the night sky. So we wanted to show you where to find some of them and also what they look like close up. And all the objects we're going to show you, if you have a telescope at home, you can actually try to find them. Charles Messier's telescopes weren't that great. So if you have a modern scope at home, there's a good shot that you would actually be able to see some of these objects looking pretty nice. And some of them are visible to the unaided eye as well. Okay, so Nick, what time are we looking at? Is this still about the current time today?
Yeah, this is still the current time right now. And if y'all want to kind of track the time as we move forward through the session, it's going to be here at the bottom of your screen. And it's a little maybe out of order from how we're used to seeing the date and time. It's 2020, 07 is July. Today's the 9th, 9. And this tells us we're right here a little after 10 a.m. But we need to change that, right, Amy? We need to make it later.
Yeah, let's make it later.
Sure. So in the real world, you have to wait for every second to go by to be able to, fast forward to nighttime. But in Stellarium, you can speed it up. And I know it looks a lot, probably to you, like the sun is moving across the sky. But in reality, the sun's not moving around us. It's the Earth that's turning. Our Earth spins or rotates every single day. So that's why it appears that the sun is moving across the sky. So as we get later, we're approaching about 6:30. Our sun is going to dip behind this big tree here in Stellarium. And we'll start to see a glow of a sunset. And then some of the bright stars and other objects in the early evening. We're going to take you to about right here. It's about 10 p.m.
And that's how late you got to stay up this time of the year if you want to get a dark sky. Nick, I see lots of bright things. Stellarium marks brighter things with bigger dots and sometimes with labels as well.
Exactly. And I figured what we could do before we start to kind of hone in on some of these deep sky objects and Messier objects is to find our way around to a few bright guideposts, a few bright stars in the sky that can help us kind of get our bearings when we're looking. One way to do this is to find a really familiar shape that's not completely outlined here because it's so high up in the sky, sort of towards the north. I told you we're facing the south. The very first thing I want to show you is the Big Dipper. Now, you can see the part of the Big Dipper that we really need in this view. The Big Dipper appears as 7 bright stars. 3 in the handle, 4 in the bowl. I can tell you right now, you can only see 2 of the bowl stars. But I'm going to go ahead and outline it for us just to demystify this a little bit. Maybe you could imagine the rest of the dippers here. There is a reason we're not swinging you around to see the north because we're just using the Big Dipper as a guide. But you see this handle of 3 stars right here. That curve, maybe you even think of a curve as an arc. That arc can help us arc to another bright star, Arcturus. So if you can find the Big Dipper, even in your city sky, as long as there aren't too many clouds, you can point your way to another bright star. So again, we're going to arc from the handle of our Big Dipper within Ursa Major to Arcturus. Now, Arcturus is one of the brightest appearing stars in our sky. Again, you should be able to see it pretty well. And it's part of a constellation called Bootes, the herdsman. Here's how you spell Bootes, B-O-O-T-E-S. And just for fun, we'll put up what we can imagine some of these shapes to look like. But as much as I'd love to tell you stories today, that's not quite our purpose. So let me help you find another pattern that's going to get us started on where some of these deep sky objects are. So along with the Big Dipper and Boötes, another prominent shape in the summertime is called the summer triangle. That might lead you to think we're looking for 3 bright stars that make up the points or the vertices of this triangle. So as you look around here in the sky, you probably see lots of triangles. This one stretches across the Milky Way. It takes up a pretty big patch of your real life sky. And one of the stars within the summer triangle is already labeled. It is called Vega. It's the brightest star in the constellation of Lyra, the harp. And this is the outline of the harp. Vega's one point of the triangle. Move up this way, you find Deneb, which is the tail of Cygnus the swan. We'll put up some labels here so we can see those as we move along. Vega is part of Lyra. Deneb is part of Cygnus. Here are the pictures of the harp and the swan for you. The last piece of the summer triangle is Altair, part of Aquila, the eagle. So we wanted to outline these because a lot of the objects we're going to talk about are in this region of the sky. So we got kind of lucky here in the summertime that we have lots of fun Messier objects to point you towards. One last thing, we're going to use a couple of these bright stars that are already labeled to help us find a constellation that's actually a little bit trickier to find by itself. And the way we like to do this is by finding Arcturus, by finding Vega, drawing a line right in between them. So draw a line right in between these. If you draw that imaginary line in the real sky, it's going to bisect or cross through a constellation called Hercules. And I always find Hercules by finding this fun little, it's not quite a parallelogram, but this fun little keystone shape here. And really, I just look right in between Arcturus and Vega. Hercules, the great hero of mythology. Here he is, looks like wrestling some sort of creature or another. But Hercules is a little tougher to find in your real sky. So using some of these other bright stars can be helpful. And we point out Hercules because there's a really cool Messier object in that region of the sky.
Yeah, so kind of in the side of the keystone is a globular cluster. And next to using the search function in Stellarium to show you where it is. And so if you look for Arcturus again and Vega, draw a line in between, you get pretty close to M13, the 13th thing on Charles Messier's catalog. And when he looked at it, and if you look at it on a dark night from a dark location, you will see a fuzzy thing in the sky. And you, like Messier, will probably not be able to tell that it's actually, there are individual stars there. The stars are really closely packed together. And so they weren't actually resolved as individual stars until years after he added that object to his catalog. Nick, I wonder, could we see a really nice close-up picture?
Sure. Well, one neat thing is in Stellarium, you can use a zoom function to try to get a nice image. And for some objects, this one actually has a pretty good one. They put in nice, beautiful images. You can see kind of this big square of the sky here. So this is what that globular cluster in Hercules might look like. We do have another image for you, though. Maybe a little more color correction, and you can see even more stars within this cluster.
Yeah, so we're looking at over 100,000 stars. And I saw that somebody had asked a question about how far away deep sky objects are. Well, by definition, they're past our own solar system. So that puts you in the distance of at least light years. We're going to be looking at a star cluster that's hundreds of light years away. This globular star cluster is on the order of 25,000 light years away, still within our own galaxy though. Within the Milky Way galaxy, but there are other deep sky objects that are outside of our Milky Way galaxy. They're actually other galaxies. So we'll show you objects at a variety of distances. 25,000 light years away means that if you send a signal at light speed to this cluster, it will take 25,000 years to get there. And in fact, we have done that. In the 1970s, we sent a very powerful radio signal. And this is it. It was a picture that we sent, except via ones and zeros. And it's a picture that tells any aliens who may be out there that what we look like. You might be able to see a stick figure representing human form. Also, there's some information about our solar system and about the DNA and other important biochemical elements, let's put it that way. If there happen to be any aliens hanging out in M13, the Globular Star Cluster, and Hercules, and they want to send us a message back, well, it's going to be at least 50,000 years before we hear back from them. 25,000 years for the signal to get there, 25,000 years for a signal to get back. And that's traveling at the speed of light, fastest thing in the universe. Okay, so that kind of gives you an idea of how far away some of these objects are. And we've got another one we can show you that's closer to Vega.
Yeah, so we're hopping back. There's going to be a little bit of hopping back and forth today. So if you see me whipping the sky around, never fear. I'm just trying to get you in the right location to find some of these things. But we wanted to try to organize this as you could see these objects through the night. So as Amy mentioned, we're going to move over towards Vega. And what we're looking for this time is something a little bit different than M13. It's not a globular cluster. Its number is M57. And you see, even though I'm an experienced stargazer, I still need to use this search function to figure out exactly where these deep sky objects are, because if I went about just clicking around, it would probably take a really long time to find it. But
and
M57,
this is an object that we often look at in sky watching sessions, M13 and M57. M57, the Ring Nebula. This one's much closer than the globular star cluster we just showed you. This one's only about 2,000 light years away. So still very far away.
and if we were to zoom, again, you have a kind of neat picture here in Stellarium, a blurry picture, but I think we can show you an even better one right here. This is the Ring Nebula. And with a little bit more detail, you see lots of color and kind of different representations of the gas that has been pushed away from this white dwarf star. So the Ring Nebula is really interesting because A, it's beautiful, but B, this type of nebula is what the eventual fate of our solar system holds. So, you know, we get the question all the time, is the sun going to blow up? Is it going to cause a supernova? No, it's not going to, you know, create a black hole here in the middle of our solar system. But on the order of 4.5 billion years from now, the sun is going to change, and it's going to push off lots of its material into the surrounding space. And where our solar system currently is, there will be this area called a planetary nebula. So it's kind of neat to look up at the Ring Nebula and see maybe what the future of our solar system is going to look like. So imagine this star used to be a lot more massive and a lot larger, but it sent much of its gas out into space around it as it changed throughout its lifetime.
And we should mention, if you have a telescope at home and you look at the Ring Nebula, it will not look like this. It will look more like a smoke ring or a gray Cheerio.
Still very impressive, but yeah, you don't get all this nice color through your backyard telescope.
It is really cool, though. I actually love seeing this object.
Yeah. Okay, onward. We have a number of other things to show you. Before we get into a couple more deep sky objects, I have a couple of more wayfinding constellations to show you. These are two that we've mentioned before, and they're very, very prominent in your summer southern sky. We're going to be looking for Scorpius the Scorpion. You can find its bright red heart, the heart of the scorpion, and Antares. Very visible, even if you're, you know, in the middle of a city. And we're going to be looking for Sagittarius, which to our eyes, I already outlined it here, but it kind of looks like a teapot. Maybe you can imagine there's a handle, a lid, a spout, a base, and then there's all these other things kind of coming off the teapot. That's because in mythology, Sagittarius is supposed to represent a centaur, half man, half horse, and he's an archer, so he's carrying his bow and arrow. I see a teapot. I don't really see a half man, half horse archer, but you know, that's the beautiful thing about imagination. You can see lots and lots of things there. But we show you these two constellations because in this neighborhood of the sky, we have a couple of other really fun deep sky objects. So I think next, Amy, we're going to go to M7, which is called Ptolemy's cluster.
Yeah.
As I've done before, I'm going to have to search it right here to make sure I get you right to the right thing. And you see that this is really easy. What I'm pressing is F3. That's my hotkey to bring up the search window. You can also do it by coming over here and clicking on search window. But you can just type in your object and there we go. Stellarium finds it for us. It does adjust your view a little bit, but that's okay. M7, we think of it as being somewhere in between the stinger of the Scorpion and the spout of Sagittarius. So let's zoom in on that. And again, Stellarium gives you an image, and you can tell it's kind of like a blurry image, but I think I have an even better image for you of M7. I think this one is just gorgeous. M7 is called Ptolemy's cluster. It's an open star cluster. And the cluster itself contains maybe about 100 stars, which are some of these brighter objects there. But as you can see, when we get a telescope image of this, you see millions of other stars within the background of it. The cluster itself is about 200 million years old. It's 25 light years across. And folks have been looking at this one for a long time, maybe even before Messier. It got its name, Ptolemy's cluster, because it was noted in 130 AD by Ptolemy. So I think this is a neat one, and it's a different type of object than the nebulae or other type of clusters we showed you.
And if you have binoculars, you might take a look, see if you can spot it, and you'll be able to pick up in the same field of view another cluster, the butterfly cluster as well, M6. So you could get in binoculars the 6th and 7th object on Messier's list. And Nick, I see we're getting tons of interesting questions coming in, so I'll be brief about our next object. It's M8 is what we'll look for, and it is in Sagittarius. And if you kind of take the teapot lid, I sort of imagine flipping it up like a hinge, and you would land on M8, also known as the Lagoon Nebula. You can see this with your unaided eye from a dark sky. I have seen it. I was once at the far southern end of Bryce Canyon National Park, which has very dark skies, and saw it just naked eye. Of course, it did not look quite like this. It just looked like a fuzzy patch on the sky, but it was really obvious. It's a giant cloud of dust and gas that's creating stars, and it's also home to young star clusters. It's about 5,000 light years away, and it's what's known as an emission nebula.
Yeah, it was one of my very favorites. When I first started working at Morehead in 2007, we were cleaning up summer camp classrooms, and I was given a big poster of the Lagoon Nebula, and I still have it. It's one of the most beautiful ones to me.
And I know that the next object we're going to show, Nick, I think this one's one of your favorites. And we've shown it before, but it's so good, we have to show it again.
Yes, and I love that you guys have so many questions, so I apologize. We're going to zoom through these last few objects so we can talk to you. This one is called M16, or the Eagle Nebula. It's still in this area of the sky. I'm going to outline two more constellations, Ophiuchus and Serpens. You can see that Serpens actually kind of wraps around Ophiuchus, who is supposed to be the serpent bearer or the healer of the sky. I outlined both of these because the Eagle Nebula M16 is within Serpens, and you'll see when I type this in, we're down here in this neighborhood. This is one that y'all might have seen before. As we zoom in here in Stellarium, you can see a lot of gas kind of surrounding this cluster, but this particular part right here is a pretty famous space image, and I can show you a picture that's a little bit better. Here is what some call the pillars of creation. And there are all sorts of really neat images of this that are even more zoomed in on this particular part. But it's part of this larger Eagle Nebula. And the pillars have all sorts of ultraviolet light kind of moving through them from a cluster of young stars behind them. So that's one of the reasons we can see it so nicely illuminated. And those pillars, that gas that you see here, those are star forming regions. So new stars could be being born just within these kind of interestingly shaped clusters of gas. I think of it kind of like how you look at clouds in the sky. You can imagine this shape to be a lot of different things. And it's going to change over long periods of time. So kind of a famous space picture, but it's a Messier object as well. Okay,
so I think if we want to see a couple of really great last objects. We're gonna have to stay up later. You can actually see all Messier objects in a single night if you pick the right time of the year. This is not actually the right time of the year to see all of them. There's over 100 of them. But we can pick up a few more if we're willing to pull an all-nighter, basically.
See the moonrise here, a little after midnight. Also the planet Mars, you might have noticed that. But yeah, we're going to stay up really late. We're verging on early territory because we're moving about to, I think, 5 a.m.
Yeah, so we should pick up Venus soon. There it comes. Venus is absurdly bright. The only thing brighter is going to be the moon.
Okay. Well, I think since we do have so many good questions, this might have to be our last object. We could probably talk all day about all these wonderful deep sky objects, but this one I think is one of the most mind-blowing. We have talked about it before, but I encourage y'all as we move through the summer and into the fall to try to find this yourself. We're going to be looking for another galaxy outside of our own. So to do this, what I usually do is I find the constellation of Pegasus. Pegasus has a great square. Some folks call it the Great Autumn Square. So that can be pretty visible. And tonight it's, above Mars and the moon in the sky, but that's not going to be useful for you every night. And again, this is about 5 a.m. From Pegasus, which if you see our artistic representation here, it's a flying horse. From Pegasus, you can also find the constellation of Andromeda, a beautiful princess up there in the sky. And what we are looking for is Andromeda's galaxy, which is also known as M31. So what I usually do, I know it kind of spun us around here. I don't love that it does that, but anyway, it spun us around. What you can look for in the real sky is a fuzzy patch. This is something on a clear, dark night that you can see without a telescope. You won't be able to see it in this great detail that we're going to show you, but this fuzzy patch of the sky is visible with just your eyes. And it's one of the most distant things you can see with the unaided eye. It's incredibly, incredibly far away. We're talking millions and millions of light years away. But this is a galaxy separate from our own. And some folks think that Andromeda has even more stars than the Milky Way. So we estimate somewhere in the neighborhood of 200 billion stars in our galaxy. This galaxy could have even more than that. And if you've ever kind of dug into a little bit more about the Andromeda Galaxy, you know that Andromeda and the Milky Way are on a collision course. Our galaxies are moving towards one another, but never fear. It's not going to happen for a really long time. And when galaxies collide, it's not as cataclysmic as you might think. The stars actually very often pass by one another rather than crashing into each other. And it'll probably form some sort of fun, interesting, irregular galaxy once that collision happens. We do have one more image of Andromeda that I just love. You can see the light from so many stars. So Amy, I think this means we might have to do another Messier object session because we had so many other things that we wanted to show you. But for now, since there are so many great questions, I think we'll kind of move on to talking about those.
Yeah, although we should pop up our poll. If you'll, everybody who's watching, if you can go ahead and answer this question for us, it helps us understand how many people are watching this program right now. So if you can just let us know how many people are watching this program on your screen. If it's just you, you would check the 1. If there's 2 of you watching, check 2, and so on. And that would help us out. Thank you for doing that. And then, Nick, where do you want to start? I see tons of excellent questions.
Yeah, I have a couple that are kind of related that I'd like to start with. The question is, what kinds of gases are present in a nebula? And related question, why does the Ring Nebula have blue in it? So gases in a nebula are the same gases that are part of a star. Mostly what you see when you see these big clouds of gas are hydrogen and helium, the most abundant gases and elements in our entire universe. They're the lightest. They're what most stars are made out of, or they make up most of the massive stars. And so when stars blow up or in their lifetimes, they send that hydrogen and helium out. Now, there are other types of elements present in those gas clouds, but most of it is going to be hydrogen and helium. So to answer the color question, the colors are a way for us to tell the differences in types of gases inside of a nebula, or even, you know, in this image that we see of Andromeda right now, the colors help us tell the differences in types of stars and temperature and size and all sorts of things like that. So as Amy mentioned, when we were looking at the Ring Nebula, if you look at with just your eyes from a telescope, it might look kind of gray. But if you use something like the Hubble Space Telescope, you're able to capture a lot more detail from these things. And when we process those images, we can use colors to kind of show the differences. So that's why you might have seen blue. I don't know what exactly the blue corresponds to in that image. That could give me a little bit of homework, but the different colors are a way for us to kind of tell the difference between what's happening in that image.
Okay, Nick, we have time for one more.
Yeah, absolutely.
Okay, let me look. Hima's got a couple of questions about what constellations and star patterns are visible when. So let me just tackle one of them. Is the summer triangle only visible during summer? I personally think the summer triangle is misnamed. I would call it the summer-fall triangle. It is well seen throughout the fall, December even. If you go out right after it gets dark, after sunset, it's still very prominent in the sky. But summer is a good time to see it. And then a related question about, are there any constellations other than the Little Dipper that stay visible throughout the entire year? So yeah, for our latitude, where we are in North Carolina, a certain portion of the sky is what's known as circumpolar. It's always up. Those star patterns are always up. That includes basically anywhere near the North Star. The North Star is part of the Little Dipper, so that means the Little Dipper is up all night long, all day long for that matter, and all year long. And anything in that vicinity, so that's going to include constellations like Draco and most of Ursa Major, the Big Bear, and some others as well. Now, your mileage may vary if your latitude varies. So if you are living at the North Pole, the entire sky is circumpolar. It just slides around like that, everything all the same. And then if you're near the equator, then basically none of the sky is circumpolar, which means that the constellations are always changing that you get to see. Nick, I don't know if you want to add anything to that or if we are out of time.
I think that's a wonderful answer. And I see that there are so many more questions. We wish we had more time to talk with you today, but join us next week. We'll be back on Tuesday at 10 a.m. So if you liked this session and you like this sort of content, we encourage y'all to go to our website, www.moreheadplanetarium.org. That way you can navigate to all sorts of resources about your night sky and science in general. You can find the Morehead at Home page there and see a big list of what we're doing virtually in this time. Also, if you're a social media person, you can check out our Facebook or Twitter or Instagram. I highly recommend our YouTube channel because these sessions that we do twice a week are posted on there afterwards. So if you ever want to go back and revisit something, if you missed one and you're interested in hearing what we talked about, those are posted there as well for your learning. If y'all join us next week, maybe we can try to answer some of these same questions, but otherwise, we'll see you next time. Bye.
See you next week.